Hello and welcome to my shop. I'm going to be working on this radio some more. I think we're going to be doing voltage tests today. But first, how about a riddle? How about a riddle? This is a riddle I was told, or I read when I was a kid. I'm sure a lot of you have heard this riddle. There's a container. This container is empty now. I'm going to put something in it, and exactly 1 hour later the container will be completely full. What am I going to put in? I'm going to put into it a virus. There it is. I put it in. It's in there. Now the thing about this virus is it duplicates itself or doubles every minute. So right now there's one in there. A minute goes by. Where's my watch? A minute goes by. There's 2 in there. Another minute, 4 in there. Another minute, 8 in there. Here's my riddle question. Since we started this at 12 o'clock, and at 1 o'clock we know it's full, what time is it when it's half full? And the answer is 12:59. Think about that. If you didn't know this, if you hadn't heard this riddle, think about that. That means this container looks pretty much empty until literally the last couple minutes. And it fills. Guess what this is a model of? You know what I'm talking about. Okay, now, I think it makes some sense at this point to go through and try to test the voltages on the tubes. That's really what I'm after. The screens, plates, grids, if I can do it, and see how they compare to what they should be. And we have a pretty extensive manual for this radio, and I haven't even checked it yet, but I'm pretty sure it must have voltages written on it somewhere. So let's go take a look at that. So I might as well take a little advanced look at the schematic information I have. Anyway, stringing diagram. This is a location of all the tuning adjustments here. Interesting thing is, look at how these are laid out. They're not quite the way I would expect anyway. 1, 2, 3, 4. That's just a bit of a... I kind of thought, you know, these were FM, and well, maybe they are. Well, I don't know yet. Anyway, that's how they're numbered. That's what I know. That's how they're numbered. Okay, let's look at another. Okay, here's a schematic now. Make this a little bigger for us. And are there voltages on here? There we are. They're in square boxes. Okay, guys, look for square boxes. Square boxes. There's one here, right on the plate. Screen. Plate. Plate, screen. So they're giving us the screen and plate voltages all the way through here. Magic eye. We can probably deduce it because it's going to be the same as this. 212 out to here, and this is probably the same as something else. I don't know. No, that's not a screen. Okay, so the voltages are on here. We don't have to look any further. Let's look at the output tube for a moment here. So the grid is driven from the plate circuit of the previous tube, which is normal, and is protected from the plate voltage by this capacitor. So this is a very important measurement to take here. So here it gives the what is ultimately the bias voltage developed across this resistor, which is in the cathode circuit. So we want to check that one too. They didn't put a voltage right here. Great. No, it's good. It's good though. Anything else I need to look at on this before we get going? I don't think so. Oh, someone's just come to visit me. I think she's saying, go outside. Shadow, you were outside and you wanted to come in. Now you want to go back outside? Just shut up and let me out, she says. I don't understand English anyway. Say hi to all the viewers. Good cat. Well, I will have to stop now and deal with the cat because otherwise we're going to hear that meowing for the rest of this video. Isn't that right? Yeah, that's right. Okay, out she goes. Okay, I think I'm going to start, of course, right with the power supply. I'm going to use this meter over here, which you can't see at the moment. Look a little better, and I'll get it visible in a second. Not to worry about it. All the measurements will be made to the chassis. Clip on there. Made with the DC probe. Good, we're all set to go. Wow, pretty hard to spot the tubes in there, but I'm sure I'll be able to manage it once I get going. But there's something a little bit interesting in here that I noticed. It has to do with the some grounding straps. I'm just going to point this out, for what it's worth. So my eye fell on this metal bracket that runs from the back apron up to the front here. Appears to be just clipped in place. Maybe that's the answer right there. You see this big grounding strap coming from a point here, grounding braid. You can see another piece going from the same point here up, soldered nicely onto the chassis here. I'm going to guess that this piece is grounded by this strap because it's only clipped in here, and it can become potentially an isolated piece of metal floating in the back of the radio, which you don't want, because an isolated piece of metal, like my screwdriver shank, becomes an antenna right away, and it can convey actual radio signals back and forth in the radio, maybe set up an oscillation or something like that. So I would think. So I think that's what they've done here. They brought this over, and look at how heavily it's. I mean, this is a heavy strap, heavy. And look at this. This is the two filter capacitors. This is probably the one we need to test right here. And one terminal is soldered to the chassis. But the thing to look at, look how much solder they put on that. Oh my gosh, it's a huge blob here. They're really soldered in there good. So anyway, just things I notice. Just things I notice. Okay, volume is down, switch is off. We'll put it on AM here. Make sure the volume's turned down. Speaker's still connected. Power's going on. Okay, first by dim bulbs. Always keep an eye on the dim bulbs. Okay, it's good though. Let her warm up a bit. Give it the full shot. Make sure we hear something. Now we'll take a look at that schematic while it's warming up. Good. Let me just zoom in on the area of interest here. This it might be a little hard to see on your screen. This guy right here. Just following the line up. And then on the other side of this, it's 250. It's 250. Isn't it 250 down here? Wait a second, how's that happen? Wait a minute. No, go further. Here, 260. So we've got 260 here, 250 there, 10 dropping on the output transformer. Okay, let's see if we can find it. Oh, I gotta get this meter a little more visible here. It's probably my overhead light that's really doing it. Let's try that. That's a little better. It's probably not my overhead light. It's probably this one. There we are. Here we go. Okay, now we can see things. More or less. So the scale I have this on is 500 volt scale up to here. So where did the okay. I lost track of it. Oh, there it is. No, I've lost track of the Jim, it's gray. It's right here in front of your face. Okay, I got it. Sometimes. Okay, so we want to go after those filter capacitors down there. I might get everything on the screen at once. So here's one that connects to the other. It's kind of interesting. Let's start with that one. So the reading on my meter there is 280. Try this one. reading there is 140. Here, 140. Here, 240. This is a 2-terminal capacitor. This is a 3-terminal capacitor. One of these is probably, no, I was going to say it's probably the bypass, but if it was, we would see 7 volts or something. Bypass for the output tube cathode resistor. We would see. So the highest voltage we get is right here, where the 2 capacitors are tied together. 280, which is, you know, pretty close to, what was it, 260. And my meter could be that inaccurate. Let's see where the 0 is pretty good on it. This meter's not bad, but it could be that inaccurate. Chances are the line voltage is, maybe, oh, it's 122.5 today. That's, yeah, this is probably done with 115 or something like that. It might even say on the schematic, if we just take a quick peek. On the other schematic, it may give the expected line voltage, but I'll bet you it's 115 or something like that. Anyway, I don't think that's a problem. Let's go find the output tube now and take a look at what's left on the plate of the output tube. So the output tube is the big honker right up in here. And which pin? Oh, you know what? I did not check on the schematic to see if the pin numbers were identified. So they do this a couple of different ways on these schematics. Sometimes the pin numbers are identified on this one. Good. But sometimes they actually show the pins in the actual order they're in the radio. So you can count them right on the schematic. This one, no. Pin 5 is the plate and should have 250 volts on it. Pin 5. Pin 5, once again, making sure I got the right tube. Right in here. I cannot see. It's so dark here. Yeah, now, pin 5. Yeah, so I got to spot first pin 1, or, oh my god. That just doesn't even look like a tube socket in there. Well, another way is to go around all the pins, and when you hit the pin of interest, you'll know it because it'll show up on the voltmeter. Oh, I can't even get my meter in there, I don't think. Oh my gosh, I'm going to have to really overlight this because my light seems dim today. What's the matter with me? Let's blast it right in there. Okay, now I can hardly even tell those pins are in a tube configuration. Here we go. I was looking at the wrong stuff. That's why. Okay, first one. What do we get? We get some sound. That's probably a grid. Oh, we get a reading of, well, that would be 5. It's a tough one for me to figure out on that scale. Okay, don't slip. So on the 150, 75 volts. 75 volts. And we look at the schematic. Is something supposed to have 75 volts on it? We're supposed to see 212 and 250. Where's 75 come from? So that doesn't sound very good right there. 75 on the first pin. Let me try that again and make sure I got. And make some noise. Is that the grid? Oh my gosh, if that's the grid, this tube's in trouble. That looks like pin number 7. That looks like pin number 7 to me. 7. Oh my gosh, it's the grid. The grid is. Think for a minute. Think for a minute. I'm reading this to the chassis. It may not be valid. So I need to read. We need to skip right over to the cathode quickly. Pin number 2, and somehow manage to find that and read it. Okay, quickly, man. Quickly, man. So pin number 2 appears to be this one here. Okay, we're getting a tiny little voltage, which we should. I'm on the 15 volt scale now. Voltage drop on the cathode resistor. Get my eyes lined up here. It's right there. Okay, negative reading. That negative reading. So we're looking at it. Maybe I got the wrong pin. Pin 2, EL95 output tube. Pin 2. Should be a capacitor of significance hooked up to it, or a wire running to a capacitor of significance. So pin 2 has this black wire running. Well, who knows where it's going. It's disappearing up in here. It also has on it, what else? I don't see that it has anything else on it. But it should be tied back to a capacitor. Well, maybe that wire goes all the way over to, wait a minute, I see 70 something volts. I see 78 volts on the plate. Oh my gosh, it's on the plate of the tube just before the grid. The output tube. I'm reading the plate voltage on the grid of the output tube. This radio wouldn't operate. Then I've got the wrong tube. I've somehow skipped up to the wrong tube. How can that be? That's the output tube right there. Isn't it? Maybe not. Have I got the wrong tube? I got the wrong tube. You know why? Because I keep thinking there's a rectifier tube in here. And I keep looking at the output tube and going, that's the rectifier tube. Okay, no rectifier tube. Well, that was exciting. So we won't worry about those readings. We'll try to do the right thing. Okay, the right thing is, oh, it's even worse. It's down under here. You can see the shape. There's the shape. Okay, now we're in business. Output tube. That's the bypass capacitor right there. And one of these two is going to be the cathode resistors. I think if we can read the cathode voltage right here. We cannot. We're getting some huge voltage there. Okay, I'm wrong about what I said. I'm wrong about that. Okay, just get my head in gear here. So the pins, the tube is in differently. The pin 1, pin 1. Why do we even care about pin 1? We want to go after pin 5 and check plate voltage at 250. Pin 5. Pin 5. Okay, I see what's up here. Woo! Careful with the meter. So there's an unsoldered pin. Pin 1 is unsoldered to anything. Of course, pin 1 and pin 7 on this tube are the same thing. You have your choice. So what they've done is the pin 1 wire, or whatever, the socket wire, actually comes through the board. And it's just sitting there, not connected to anything. So that's 1. So this is 2. 500 volt scale. Pin 2. We want pin 5. Never mind 2. Don't worry, I'll get there. I'll certainly get there. So 1, 2, 3, 4, 5. Oh my gosh, how am I going to get a probe down in there? Pin 5. It's just hidden away in there. Oh my gosh. I think I'm going for pin 5 here. Let's count them again, just to be sure. 1, 2, 3, 4, 5. Plate voltage. Plate voltage 260. So it's all there. So we got 280 or so, and then 260 or so. That leaves 20 on the output transformer. And now we do the temperature checking of the output transformer here. Can we spin this all the way around? Put my fingers on it. There's no heat in it whatsoever. So I don't think there's any problem. Now what about that? Oh yeah, that crazy measurement was the wrong tube. So what we want to do now is check the screen voltage. Screen is 6. Should be 212. The screen is 6. So we'll count backwards from 7, 6. It's also in a very difficult spot. Pin 6. Don't move, don't move. 240. 240 is supposed to be 212, a little high. No, I'm not sure that's enough to worry about at all. At least it's there. That's the main thing, is I want it to be there. And the last thing would be bias voltage by measuring the drop on the cathode resistor. So we can do that on pin 2 to chassis. We should see 7 volts positive. Pin 2. Pin 2 is down, way down there. Pin 2. Okay, it's a tiny rise. 15 volt scale, straight up would be 7. Pin 2, straight up is 7. Here we are. So, good. Bias is good on the output too. All is fine. B plus supply is good. Now we'll just work our way back a few tubes. I'm going to assume I tested the next tube back, the ABC80, because I saw the 75 volts. And I think that's the only thing I'm going to test on that tube. We're going to go back to this one over here now. EF89. And it has a screen, has a plate at just under 200 and a screen only at 45. So plate is on 7 and the tube is where? So that tube, I think it's this one. It says 89 on it. Somebody wrote 89 on it. Is that what this tube is? EF89. Okay. I'm pretty sure I got the right tube. It's really tricky to spot the, you know, the ring around the tube socket here. Okay, I think I'm looking at it now. Can I spot which pin is pin 1, 2, and 3? Oh my gosh, that's a really toughie in there. I would think, is pin 1 or 3 grounded on this tube? It turns out 3 is. 3 is solidly grounded. 3 is solidly grounded. So if that is well, we're gonna have to go ring around the rosy here and see what we end up with. That's a pretty timely phrase, isn't it? Ring around the rosy. So we'll go on. I don't. Is that really the tube? Yep. Well, we'll just try. We'll just try some. Try this. Went backwards. I had this on a low voltage scale. Let's put it up on 500 volts because I'm looking for the positive plate voltage here. Make sure I'm on the right tube again. Nothing. That's ground. Nothing anywhere. That's ground. Somebody's got to have some voltage on it. Maybe this one. It's nothing. Something going wrong here. Okay, how about this one? This one. There's a little puny voltage there. 500 volt scale. Okay, it's 50, 60 volts. And then we're back to this one. I went all the way around and we didn't find any high voltage. Should be two spots where there's high voltage here. So that lower one, that could have been 45. Let me find it again. Which one was it? That one. Okay, 50 volt scale, so 45 will throw it right over on this pin. Okay, off the scale, a little bit hard. So 150 volt scale, this pin. So we're looking at 60 volts. What pin would that be? I think, and I'm not sure, I think that's, boy, could be pin 2. Pin 2 is grid. That's really not making sense. You really expect like pin 7 or the 60 maybe on pin 8. If this is pin 8, then right next to it is pin 7. If this is pin 8, it's right at the gap. 8? 9. There's 9 pins here. Yeah, that's why I'm having trouble looking at this. There's more pins than I'm used to seeing. Okay, so where do we think we are? Still holding the voltage there. It's 60 volts. Guessing it's pin 8. Should find next to it the high voltage. So this is next to it. I got the meter set low, so if we find it, should blow that meter right over. Okay, I think this is it. So the radio went dead. 500 volt scale, so that's 240 volts. It's supposed to be 195. That's better than expected. A higher voltage is not commonly what you find, right? Mostly resistors that are weakening tend to go up in resistance, and bigger voltage drop and less voltage for the radio or the tube. So point is, they are there. They're both high. And did our house voltage go up or something? Yeah, went up 0.3 volts. I don't think that's enough to account for it. So can't whine too much about voltages being too high. It's too low, we're really worried about. Oh, what if I flip it to FM? Does all this change? So in a lot of radios, especially in the front end, when you flip between AM and FM, a lot of voltages go up and down a little bit. I don't think that's the case in this radio though. They don't indicate it on the schematic at all. They just show one voltage. I'm on the AM band too. This is probably, is there a comment on this about these voltages? Just that warning about those capacitors that you should not touch. I don't see any notes here. There's a tube layout diagram. That would help me maybe. Okay, it's worth checking. Let me check another page of the schematic. Okay, here's the first page of the schematic, and guess what? Down here, I already saw it. There was a note. Voltages are measured with a voltmeter of 50k ohms per volt. My voltmeter is much better than that. Measurements in position FM. This is a good voltmeter, by the way. This is a fairly good voltmeter. Measurements are in position FM. So, okay, that's the problem. Well, I don't know if that's the problem. Let's go back and see what happens. Okay, so I had made an assumption here that AM would be the place to do this, and it turns out FM is the place to do it. So now what we want to do is go back to that tube and pin 89. This is the pin here. Let's double check the voltage on it. It's not that one, it's this one. There we are. So it's going straight up here. The actual reading is 230 on this meter. 230. We'll switch to FM now. We'll find out what happened. On the right tube. Okay, so now it's lower. It's 210 on my meter, and it's supposed to be 195. So, you know, that could be accounted for by the slightly high line voltage here. Probably. But that's not bad. That, I mean, that can also be inaccuracy in the meter and other stuff. So that's good. Okay. Goody. Okay, there's no problem here so far. Let's go to the other schematic now that I have here. Oh, that's not, yeah, here we go. Next tube back, ECH81. It's a very, very busy tube. 2 plates in it, different voltages. Grid here, biased by, I'm not sure, and cathode straight to ground. Potential leaker capacitor here, blocking, well, it's blocking FM, blocking, what, blocking, who knows, blocking come down here, go through here, oh my gosh, it's too complicated. So whether it's blocking any significant voltage or not, I kind of doubt it. Okay, so here we go, we gotta find this tube, ECH81. Now look at the tube chart, where did the tube chart go? ECH81 is that guy there, and which guy is that? Look at the FM box up here, and it's basically this tube. Oh, it says, you know what? It says 81 written right on it in black marker. Okay, that confirms it. So we're talking about right up in here. Another tight spot. Oh my gosh. Oh my. Okay, you got it. I got the socket clearly now. Where's the start? So the start would be, that's the end term. That's pin 9 right there. Pin 9 right there. We'll look back at the schematic for the voltages. On the ECH81. Voltages are 195 and 105, 6 and 8, and that looks like it. No, there's another one come along here, another 90. So we should have found a 90, a 195, and a 105. So it's like 2 100s and a 200. 2 100s and a 200. And I might as well look at the pin numbers. 6 and 8. 2 plates. So let's say we can find 6 and 8. I have the number 7 there. But that's for... yeah, let's not worry about it. That's the oscillator connection into the mixer tube, I believe. Use the grid of the oscillator amplifier to just feed the grid of the mixer part. Okay, get back to where you are. 6. So this would be 9, 8, 7. This would be 6. So on 6, on the 500 volt scale, we've got 200 volts. On 6, does that make sense? 6, yeah, 6 is the 200. So now we'll go to 8. 8, so counting again. Make sure I'm on the right tube. Counting again. 9, 8. I did say 8, didn't I? Did I say 8? 8. We should find 105 on here. There's nothing there. Come on. So really 9, yeah, this is a 9-pin tube, pin 8, 105. Is there anything to do with AM/FM on that? I know. Could it be? Could mean it's only there. So there's switches doing stuff over there. Let's check it again. Tube. Number 9. Number 8. Number 7 and 9. Are they connected together? 7 and 9? 7. Yes, 7 and 9. So, okay, that makes sense. So 7 and 9 are the two grids. Don't get mixed up now. 8. So there's no question this is 8. The question is, why am I not seeing any voltage there at all? 8. So, hard to believe this radio can operate with a problem like this. Is my radio? Maybe it's still on. Okay, I got it on FM, so maybe I'll flip it to AM and look again. AM. Make sure I got the right tube. Pin number 8's right between 7 and 9. Here it is. Now it's there. Well, you little liar, you schematic. You say, have it on FM and make these measurements, and then you come along and do something like this. So the actual measurement is 500 volt scale, 100, right? It's supposed to be 200 and 100 and 100. So there's the second 100. And now the last one we want to get is the voltage on pin number 2. It should also be about 100 volts. Pin number 2. Okay, 2. So easy to make a mistake. Pin number 1. I think this is pin number 2. So what do we got? We got something pretty low there. So on pin number 2, 500 volt scale. I'm going to change the scale. We'll put it on the 150 volt scale. Now I got to find pin number 2 again. What I think is pin number 2. So the reading now is 75 volts, and it's supposed to be 90. Now we're going to switch over to FM. I see if I can do it while I hold the voltmeter on. This is where things go wrong. And there it goes, up to the expected voltage. Someone's at my door. 90 volts. That's almost 100. Well, I think we're done with voltage tests. I think everything checks out good enough. I don't think there's any doubt of that. So, good. Now, the next thing is to consider alignment in this radio. As I mentioned earlier, a lot of the slug-tuned parts are waxed up, and they're waxed up really thoroughly. So I have huge doubts about making any adjustments of any sort on here, but I'm going to look into it. So I think we should start by looking at what the manual says. So the chart here you're looking at is the alignment chart, and I guess there's no, alignment chart AM. The RF input level should not be higher than needed. Okay, and then here we are, all these different languages. 460 kilocycles. You know, we can check this, but as for adjusting it, I don't know. Transformer 1 and Transformer 3 get adjusted, and then another AM. So here we must be L11 for 600 and L12, and these are probably waxed up. And this is going to be the I don't know what to call it. Is the interface circuit between the test equipment and the radio antenna connection. Occasionally called a dummy antenna. Shame. What's this? AM here. What? Oh, oscillator. And then the RF circuit. Interesting. So usually they lay these kinds of tables out, and you do a whole broadcast band, and then you do the whole shortwave thing and FM. But this one, they've laid it out so you do all the oscillator stuff first. And then you go back and you do the front end tuning. Minus 100, no, 100 ohms plus 22. So it's pretty specific here about how they want you to feed into the radio. It's varying from band to band too. Minimum, this is probably a trap of some sort. I have absorber circuit, so that's to trap out the 460 probably before it gets to the antenna. Sensitivity measurements, and then a look at the layout of the circuit board. Okay, do I really want to try this? Well, one thing we can do is we can try to figure out how well it's aligned right now before doing anything. That would be a good idea. Usually I find that out by twiddling the alignment adjustments and then find out if things are getting better or worse. But I can't do that here. So I have to just apply some kind of signal and see the response. You know, part of doing that is just tuning in radio stations and oh, my poor cat is just crying to no end out there. Let's go see. What's up? What is it? They just don't know what to do. We've had beautiful weather for the last few days, and then today it's crap. And the poor cats, they just don't understand what's going on. Who took away my beautiful weather? They can't go outside because it's too wet. Poor guys. So I'm going to stop and think about that. This may be the end of today's video right here, and then tomorrow I will carry on with the alignment check and basically performance check on the radio before backing it up, because I may be at that point. I didn't check the voltages on the Magic iTube, but I don't think there's any need because the Magic iTube is kind of self-checking. It works. Okay. Time to stop for a while.